Go.
Hello, everyone. Welcome to Practical GCP. In today's session, I would like to talk about the BigQuery partitioning strategy in different use cases. So I'd like to cover all the different kind of supported partitioning. So that includes the ingestion time-based partitioning, time unit column partitioning, integer range partitioning. And finally, I would like to talk about the limitations with the partitioning technique, and also there's a mitigation options on those issues. To start with, I would like to talk about the ingestion time partition. So ingestion time partitioning, as the name suggests, is basically a mechanism to automatically partition your data based on when the data gets landed on BigQuery. So this partition time column is a pseudo column that you can't actually see it from the table preview or the table schemas, but it's still there. It's automatically generated when you put data into the table. So this is actually quite convenient, and it's very, very useful for the ingestion use case when you get data from upstream systems. So let's look at a real example in BigQuery on what it looks like. So for example, this cycle stations by ingestion timetable, right? This data, as you can see, we have 1,574 rows. And you can see I've created this yesterday, and I put some data in there yesterday, and I put in some data in there today. In the schema, you have all of these columns. In the preview, you have the preview of all these columns. But as you can see, there isn't this pseudo partition time column in the schema on the preview. But in the details page, you can see the column is actually there, and is as it displayed in here. So basically is partitioned in this case, particular cases by date. So when I query this table, if I query it based on the partition time, as you can see, I've converted to a date column because it could be in this column could be it had different kind of positions. So in this particular case, I convert it to a date, and when I look for today, I've got 787 rows. If I look at yesterday, I also have the same amount of rows. Basically, I've ingested the same data twice. I did it once yesterday, I did it today. This is very convenient because in most of the systems, if you look at this particular use case, right, you've got all of these columns, but there isn't really a column in here you can actually use it as like a partition date, right? You can't choose install date as the partition date because you don't know exactly what that is. And it can go backwards. The data can be null, it can be wrong. So it could be all sorts of problems that you're having using any kind of particular column that coming from the upstream systems as the partition date. And also there's another reason. Let's say even if you can generate a date in here or generate a timestamp that you can use as a partition date, where are you going to do that? So you need to introduce another process in the middle to generate the data on the fly, then putting into this table. So that's extra work as well. So typically in most use cases, you just want to get the data in there, right? You're going to get data into a partition that you can benefit from the cost saving when you query it. And when you query the data, in this particular case, you can just use the partition time column, which has the date or the date time generated as the data land. That means there's one last thing to do, and is whatever data that lands in is basically at that particular time, your data is in there. So when you look at the data, you can always say, oh, I want to just go back to yesterday or the last 2 days, the last week, then you can benefit from cost saving automatically. So this is typically very often used for ingestion use case. Okay, so now let's talk about the time unit column partitioning. So this is kind of very similar, but instead of using the automated time generation, you can use one of those data types to partition the data yourself. And so here is suppose date, timestamp, and date time. So this is slightly different because it's typically used for a use case that, in my opinion, for kind of modeled data. So what I mean by that is if we look at the other use case here with a cycle hire by start date. So the cycle hire data set is basically just like a quick introduction of what this thing is. So it's helpful to understand what we're actually dealing with here. So imagine this table is basically all of the bike hires, right, in history in the TfL London data set. So let's say this is a table is actually quite big. You're talking about 24 million hires, right? So that's what we have in this table. So the rental ID is the primary key, and you've got all sorts of other columns that containing the rental information of the hire. So as you can see in this table, I partition it by the start date. And the start date, let's have a look at the preview of the data. The start date in this case is when the bike at exactly the timestamp when the bike was hired, right? And then you got when the bike has been returned, which is the end date, has the kind of timestamp of when the bike has been returned. So this is where it gets interesting. So when we partition by the start date, in this particular case, let's imagine when we query the data, right? We might want to understand, all of the bikes that's been hired between a particular time frame, or let's say this might be example, right? Let's say I've got some data here. Let's say the start date is this, right? The start date is the 21st of February 2016. So first of all, you can see you get the cost savings straight away. It's only scanning 4.5 megabytes of data instead of scanning the whole table. And now you can understand, how many bikes has been hired within that particular day. So this is actually really useful because it's, in my opinion, this kind of partition strategy is more useful to be applied with some kind of business domain in place. So in this particular case, you're talking about when based on a start date, because that's when most people, when they query the data, they would probably be thinking, okay, I want to understand the situation of how many bikes has been hired, or what actually happened to the bikes being hired within those particular date range, right? And then because you partition it by that, you get the cost saving easily. And especially in many other use cases, especially when you're dealing with more kind of reporting use cases, you might be looking at just kind of write some pseudocode. Let's say you're looking at maybe talking about last 2 months, right? So this is kind of quite a popular, quite a common use case. So you're just looking at the last 2 months of all of the bikes being hired, right? If this is the partition date, obviously you would only be charged for the last 2 months worth of data. That would typically give you a lot better performance and cost you a lot less. So that's where this can be used, and it's quite useful. And the next thing we'd like to talk about is the integer range partitioning. So integer range partitioning, as you can see, the example has been given in here, right? You have, so the example here, in my opinion, is actually not a good one. And I'll explain why. So in this particular case, you have customer ID, that is the integer column that's been stretched in here. You need to define like a range, let's say between 0 to 100, and the interval is 10. So what this means is between 0 and 10, that's in one partition, 10 to 20, that's one partition, 20 to 30, that's one other partition, all the way to 100. So the problem with this is, if you think about what actually happens in reality, right? your customer ID could be a very, very large integer, and it could be automatically generated in a system as well, right? But if you actually use customer ID as an example, in almost all of the use cases, customer ID is automatically generated auto increment number. So, but how do you define this, right? So this is where it gets tricky. What do you know the minimum of the maximum of your customer ID, right? What is the range of that? What if you have some issues with this database? You need to increase a large chunk in your auto increment strategy, and this is really clunky, right? If you imagine, how do you define the start and end of each partition? And so from my experience, this has been very painful to use and not very useful. But the integer partitioning, you can still use it, right? In other use cases, if you have, if you just know there are 10 values and you don't really have any other use cases for, other kind of partitioning, if you have like a number ranging from, I don't know, 1 to 100 for other use cases, you can still use it to partition your data to get the cost saving if that's kind of, what your usage pattern is. But I just don't think customer ID is a very good example in this particular case. That's basically the 3 partitioning mechanism or strategy that's been offered by BigQuery. One very interesting thing is using customer ID in this particular case. The integer partitioning may not be the best use case, but there's another thing that is you can use as an alternative. And I'll run into some examples on why that can be used as an alternative, and maybe you can achieve better results. And that is called clustering. So let's just quickly go through this on what kind of clustering is. So they are basically saying in the documentation with some differences on when you might want to use partitioning and when you might want to use clustering, right? In this particular case, where it says you might want to use clustering under the following circumstances, if you pay attention to the very last one, this says the cardinality of the number of values in a column or group of columns is large. So let me just explain this in a way that more people can understand. So the cardinality of number of values basically means you have a lot of values in a column. So customer ID is actually one of those, fits into those categories, because you typically have, well, you could be talking about hundreds of millions of unique values, let's say the primary key column as customer ID. And that cardinality is very, very high. So in those particular cases, try to define the ranges using a integer-based partitioning can be very painful. But clustering in this case can be very useful as an alternative. But I do want to mention that there's a key difference between partitioning and clustering. Partitioning is where data physically gets stored in different chunks or part of the disk. So when you query the data in those particular chunks, you never ever touch other chunks, right? So that's guaranteed cost saving. When you use clustering, BigQuery does not promise any cost saving to you. But the benefit of this is because the way clustering works is like you can see it as an index. So the data, let's say you have a customer ID, that is your cluster key. That column is pre-sorted in the data, right? Before you query the data is already sorted. So when you look for a particular ID, let's say a customer ID, then it's much, much easier and efficient for BigQuery to find that record for you. If you want to find customer 1, 2, 3, 4, 5, 6, right? That is probably in the middle of nowhere in the 50, 100 million customers range you have. Because the data is sorted, you can use very clever algorithms to actually find exactly where that record is with much less resources. It just doesn't guarantee you cost saving. But I'll run you through a example and why this is still very useful, even it doesn't give you the cost saving part of things. So I've got a table which I've created before yesterday before this session. This is called cycle hire by cluster key. So it's still the cycle hire with all of the rental IDs, right? But in this particular case, you can see I don't have a partition in here, but I have a cluster key in here, which is rental ID. But this is interesting. Let's try something that is think I've prepared something for this as well. Let's see what happens with this, right? Okay. Let's change the table name. So partition examples, this is in here. And then I'm looking for the cycle hire by cluster key column, right? Okay. Now you can see because I've not selected all columns, that's why it's not scanning 2.59 gigabytes of data, but it's still scanning 556 megabytes, right? When I run this query, well, it didn't take much time, but you see you've got the anything that belongs to the start station ID and it has a duration of that, but I'm like specifically looking for the rental ID, that is this number, and that is the cluster key, right? So I'll come back to this later, but I have another query that I can run in here. So what this does is it gives you a good idea of the query performance and the slot that's being used behind the slot milliseconds, right? Is being used behind the scenes when you run those queries, right? So after this is the latest query I just ran. You can see, although it says there's a 556 megabytes, it has to scan based on this clustered key. But in fact, it only scanned 10 megabytes and it used almost 3,000 milliseconds in this particular case, right? 3 seconds to get the result of this query. Okay, let's try something else. This cycle hire table, which next to it has no cluster key, no partitioning, right? So the only difference between these two is this one does not have the clustering. Let me run the same query and come back to this one, run this again. So you can see the total megabytes processed in this particular case is always 556 megabytes. So the slots millisecond in this case is actually a lot shorter. So I don't fully understand why this is, but let's try this a few times, because last time when I tried this, how can I put it? So last time when I tried it the first time, it takes a bit of time. And then when I started trying it further, then it's actually reduced in the number of slot seconds used. So let's find another record, right? Let's find a different one. This is a different ID. We'll look at this one, right? And that always scans 500. The total slot millisecond is 851. So it does reduce, right? It seems like it's doing something pretty smart behind the scenes. And now I use the cycle hire, the other table, which is the one with the cluster key, cycle hire by cluster key. Right, run this again. So you see now it's dropped to 299 milliseconds. So there's definitely some optimization going on. Start from the first one, that's 3 seconds. And then on the other side, it reduces and it reduces, it reduces. But the megabytes processed in the clustered one is also always a lot lower. So regardless of what optimization Google does, if you scan less data, in my opinion, it's guaranteed you're not going to have to need the same amount of processing, because you just typically don't need to process all of that data, right? You're processing 10 megabytes instead of 500. Okay, let me try one more time. Let's say this now the optimization has been done. Okay, let me try another ID just to see the one without the cluster key, to see if it's actually dropped below the ones with. Okay, not really, right? You can see this one still uses more processing time. This is 556 megabytes still. You see the previous one we did with the cluster key after the first optimization, it seems to have dropped to 300 milliseconds. But the one with the 556 megabytes still stays at the 1 second in this case. So it's not very consistent, but the point I'm making here is I believe a lot of you watching this video are probably enterprise in large enterprises or in large companies. So you may not be using the on-demand pricing, which is, you just basically get fixed amount of slots in your organization. You do the pay-as-you-go pricing plan. If you're on flat rate or flex rate, so this, I can talk about this in a different session on different ways you can optimize your costs on BigQuery. But if you're actually on the flat rate plan, you have the dedicated slots for each of your projects in BigQuery. So can you see where I'm going with this? Because if you're scanning less data, right, you should be using technically less slots. If you have a fixed number of slots, and if you pay by slots, it will cost you less, and things will go faster as well. So this is where I'm coming from, right? So this is, in my opinion, is a very important technique to use, especially where you need, because there are generally a lot of queries that you do this kind of things, right? It's like the good old days, people using relational databases, like they're using analytical databases. You need to pinpoint a specific record in there. So then this could become very useful for those use cases. There are other things you can read about cluster key, because it's not also limited to one column. You can do a series of columns. Then when you query the one followed by another, you also get the full benefit of the sorting. I would like to talk a little bit more about the limitation of BigQuery. So let's open up the partition table limits. There are different kinds of limits, but the one I want to particularly focus on, which seems to be concerning a lot of the clients, are the 4,000 partitioning partitions in each partition table. So this is a hard limit and cannot be raised. So this is, well, let's have a quick look. This is 4,000 divided by 365. You're talking about 11 years, right? So 11 years is not a lot of partitions, because depending on which partitioning strategy you choose, you could end up with exceeding that, right? If you've been around in using your existing data for more than 11 years, which I think most large companies are, then you will run over, right? And then that can be a problem. But it really depends on what kind of partitioning strategy you're using. If you're using the ingestion time partitioning, keep in mind all of your data is coming in. This is for ingestion use cases, right? So all of your historical stuff you can keep wherever you want to keep, but all of the new data coming in, they're always going to have the partition time of right now, right today. So that means you have another 11 years to sort out your ingestion time. And in my opinion, and especially what happened in the past, if you have to think about your partitioning strategy for 11 years later, you're probably overthinking it, right? So maybe after 3 or 4 years, BigQuery would make this 8,000, then you don't even have to think about it. So in my opinion, I don't think that's something worth worrying about. However, when it comes down to time unit partitioning, this is for the example we talked about earlier with the cycle hire start date, right? This start date, in this particular example, it could be just going back to a few years, but you might have a transaction table, right? That goes back to 20 years, if that's a valid use case, which I believe it might still be valid. So in that particular case, you run over the number of partitions you have. To resolve that limitation, one of the techniques you can use is to split the historical data and the most recent data into 2 separate tables that with different partitioning strategy. So this table here, you can assume is all of the historical data you've got, right? And partition it by the start date. So in this cycle hire example, I've got the start date as the partitioning field, but now this is used with the month partitioning strategy, with the month partitioning. So obviously for the 4,000 partition, with this case, you can have 4,000 month. So that's a lot of months. So you don't actually have to think too much about it. But with the most recent one, you can still use the date, right? So you may not need this complexity if your cost is not significant, right? If you're just talking about terabytes of data in this table, this would mostly likely to be an overkill. You could partition the whole thing per month, right? And then when someone is querying the data, it will cost you 1 month worth of data instead of 1 day. So it really is subjective to your how much data you're actually talking about. Because in a lot of the cases, the saving isn't really significant, especially if you're using flat rate costing model or the flex rate. So, but I just want to talk about if you do have a use case that you need to keep the most recent one in a separate table and then all of historical in there, you could, in the sense of making it more convenient for you to use, you can create a view on top of that, just to put the two together, right? So you've got these two, the most recent ones, you need all of the records in the historical ones, expose all of the columns, and then now you can query it, right? So you can just query like this. So you can see this actually scans 5.2 gigabytes in total, which is the total amount of data in both tables. But because I've exposed the partitioning column, which is the start date in this particular case, if I put a date in there, let's say 2017-0101, right? So you can see that now the scan drops into 956 megabytes. You might be asking, oh, what if there are duplicates? What are you going to do with the duplicates? So one thing you can do is to use a window function or analytical function, such as row number, which is probably the most commonly used one, to find the latest ID that is the primary key. So in this particular case, it's the rental ID of a particular rental, and then sort that by the start date of the rental in a descending order. So this row number would then give you the latest version of the rental. So, and then you can see when you apply this filter, you would get all of the latest versions that you need, right? That's all of the latest versions. And also you might be wondering, why don't you just put this dedupe logic inside the view, right? That's very convenient. If you do that, that's very useful, and then you can just don't have to think about it. The problem with that is if you are, well, let's just try it, right? So just keep in mind, right now you have this, you can see there's a cost saving in here, right? Let me put a star back. So that gives us all of the data. So if I put this date in here, if I remove the date, it scans 5.2 gigabytes, right? If I put the date back in, it scans less data. So this is the cost saving, right? Now let's put this logic inside the view. I'm just going to go and edit the view. Right, so let's say if I put this in here, right, row number, and let's say this is ranked, cycle higher as this, then we do a select, just get everything out from this, where the raw number equals to 1. Need a comma here, so right, that's our view. So you might be thinking, okay, we've now exposed the partition column, right? Then we should be able to use it later on outside of the view. Perfect. So this should just give us what we need. Let's save this. Okay. Now our view is updated. Right now it has the row number, and we filtered by the row number. Okay. Now if I get all of the data in there, where the start date, let's say I still want to do 2017-0101. You can see it hasn't actually done any cost saving for us, right? And that could be a huge problem, because if this table is hundreds of terabytes, right, and then or tens of terabytes, you just want to look at the most recent data from it, then this can be very costly. And my understanding of the reason is, if you think about what actually happens in here, in the view, this data is not filtered because you can't filter it, right? You want to expose this to downstream systems to do the filtering later on, or whatever they need to do to kind of filter the most recent data out of the last 2 months, last 1 month. And then here we're doing a rank in this, right? And then we get all the columns out, and then we filter the latest one out. So if you think about how the row number thing works, because the partition is like a scan. It scans all of the rows and figure out where, by start date, which one, how it ranks in the whole kind of row by row basis. So each rental ID, it will have in this particular case, if you have duplicate, you have 2 rows, right? But it has to scan the whole thing to do the rank. So you already actually scan the entire data, the entire tables, both tables, in order to get the rank going, get the rank correct. But then even when you later filter by the start date, you're still not achieving any cost saving, because you've actually scanned the whole thing early on. So unless you apply a filter, so ideally, if you can template what you pass into this view, then that would be ideal, right? But kind of there isn't, as far as I know, there isn't a way to do that. But if you can have something like a templated view, where you can pass this into here, like later on, you can actually filter it by that outside of the view, and that would be perfect, because you'll achieve the saving for us. But this is kind of a technique that you can use. If you don't put the row number filter to get the latest record inside the view, you can still get the data out. You have all of the data together. You can do another level of cleanup and filtering, and expose that data to downstream systems. Or you can let downstream systems, give them the row number they can filter out at the time of when they do it. So then they achieve the cost saving as well at that point. One thing I would like to mention is, this is the article where I've got the idea or the information on how to understand the resources or the slot that's been used, like in this query. So I'll put this in the end of the session, in the notes, so you can have a look at the article. It's a very good read, give you a lot of insights on how the query performs and how the slot time is being used and the bytes is being processed. So it's very useful information that you can look at from BigQuery. Okay, that's the end of the session. Hopefully you found it useful. I'll see you next time.
Go out!